Good evening, everyone. This is VK4GXC, once again with a much later version receiver. I posted another receiver a few days ago, and as the gears all still set up here, I thought I'd throw a few of the other receivers I've been working on. In fact, I'm quite a bit behind on making videos of the receivers which I've been playing with for the last 2 years, so there are a few in the queue. This is a Eddystone 1650 model. It's sort of late 80s, early 90s. It came in a number of different guises. This is a 1650-2A, it says on the back. Fundamentally, this is sort of the one you probably want to get. It's got the VFO and it's got a few other features on it which are make it really suitable for a manually tuned, locally controlled receiver setup. This same receiver was available with, in a purely remote section for the governments in the UK, and they had the VFO removed and a few of the other controls and features removed as well. And there's been a lot of those units actually come onto the surplus market, which required refitting all the parts that are missing, and I think there's some code you have to play around with too. Anyway, this one, again, I probably had about 18 months. Once I obtained it, was in quite grubby, condition. I've cleaned up the panel best I can. It looks okay. It's fair. The black plastic vents were all smashed up. These are all replacements. These are 3D printed replacements. Two were good, so I was able to use those as a how can I put it, as a model, and basically laid them out on a 3D program and printed out all the broken ones that needed replacing. So it's all now looking the way it is. I've just retained the loudspeaker, the 474 I had the other day, just as an output. It does have an 8 ohm output. It does have a 6 ohm output on the back as well. It's just that it was such a nice fidelity that I thought I'd just hang on to the speaker for the moment. Okay, so let's talk about this receiver. This receiver itself is typically laid out in the same sort of vintage as most of the Raycalls. I guess Collins would have been the same. Super het, with the sort of, you could buy this in a wider band front end or with a pre-selector. So it was a super het system where RF came in, it was mixed in a high level mix to an intermediate high frequency. The synthesizers in here run, arbitrarily somewhere between about 40 and 70 megs. And they mix it down to an IF finally of 1.4. That IF is where all the demodulation and detection is going on for AM, SSB, CW. And that's, again, pretty traditional for that style of unit. What I was surprised is the pre-selector on this unit, and this receiver does tune from 10 kilohertz to 30 megahertz, is actually an array of probably some seven pre-select subbands, and they actually have a tunable capacitor, and that tunable capacitor is driven by a DC motor. And on the front panel here we have wideband, or so you can select it or deselect that, pre-select, just a tunable filter at the front end. But that is actually the barrels of the unit on the bottom, and it's DC motor driving a belt, driving a variable capacitor, which is quite an electromechanical throwback for my mind, but maybe it was made economic sense for this receiver, and that was offered or not offered depending on the options you want to get with this. So just going around the front panel, it's all sectioned off. It's all got tactile membrane switches on it, and behind each the panel itself are transparent windows where you can see the various mode selections, AGC levels, and the like. So they're all sectioned off. Over on the left here is all to do with scanning and channel scanning and scan between frequencies. I won't go too much depth there, so won't burn up too much. So just to recap, the frequency selection is done by either channelization or through the standard VFO. And depending on where you want to be in the tune mode, it's free adjusting. And if you go to the channel mode, it'll light up this area here, and we can select whatever channel and then hit the enter mode, and that's where we'll go to. Anyway, I'll go back to the free tune mode just because that's some channel I'd like to use at the moment. To the right of it is all to do with basically the signal control system. So we can actually put in various attenuation, and all these are, just say, stepped. They just rotate through. You can't go up and down other than the filter selection, but all these just rotate through, which is a bit of a pain because you've got to go all the way through some of the selections, especially when it comes down to AGC, and you've got to go all the way through and come back to the one you want, which is, yeah, I'm surprised they did that. I think it would have been a lot better if they'd just been an up and down there. Mode selection, AM, SSB, CW, and FSK. So again, traditional modes for the systems. This has got 6 crystal filters in the back there. We're starting at 8 kilohertz, 3 kilohertz. I think there's a 1.2, 750, 300, and then a 100 or 200 hertz, I believe, at the bottom. Maybe 300 hertz at the bottom. And that I can show you a bit later on. Actually, I will show you the inside of this because it's not too difficult to take the covers off this one. And so to the right of the mode selection is the AGC. So it's they do have something on this radio called an audio AGC. Now, when you're receiving SSB, generally you'd normally go for the slow, and it'd be a quick attack and slow decay. But well, this is one called audio, and it's a funny sort of punchy arrangement. I have to read a bit more up on it, but it appears to be the ability to actually audibly improve the punchiness of the audio coming out under, I guess, rough conditions. But it's a different attack and decay to what you'd normally get for an SSB or for any of the other modes. To the right of that, again, is the filter selection. It doesn't give you the actual bandwidth. It just tells you the modes and operation, really, for it. There's a RF meter here, which is, it's fair. It's a bit broad. You only got 10 LEDs there, 10 LEDs on a bar graph. So it's kind of hard to really justify. But the system itself internally has 2 distinct AGC systems. One is at the IF level and one is at the front end RF level. And the intent is that as the signal levels increase above AGC threshold, the IF system starts to be wound back on its gain, and as it runs out of control range for that, it then starts winding back the RF on the front end. And the meter itself, again, it cycles through, but you have RF1, which is the front end, and RF2, which is the IF. Now, I wonder if that should have been an IF there rather than RF2. But anyway, it's two separate. I wouldn't call them independent. They work together, but they are aligned separately. And then there's a crossover point you set on the alignment, and that's yeah, it's just tricky, but it's it's what you do. Below that is a list of sort of options. You can switch the beeping off and on. So we'll turn the beeping off. You can have a wideband or pre-selector. So with it on, it's inhibiting the internal pre-selector, and with it off, then the pre-selector is enabled, and it will tune with the reason I think you do that is if you were stepping around a lot of different frequencies, you wouldn't want the pre-selector to want to try and keep hunting and trying to find where you're moving to. So you'd have it off in a scanning mode probably, and then switch it on for when you want to get that good signal to noise and good resistance to blocking and overload from adjacent signals. BFO, you can manually set the BFO up to whatever you want, plus or minus 3. Again, typical of the sort of receivers of this time. There's an internal loudspeaker. It's a bit tinny on this one. I thought it was broken. I'd have pulled it all apart there. I can't see anything wrong with it, but it just sounds very fuzzy. I tend to leave it off generally. There is obviously a remote, so you can control this from a remote, again, as most receivers of this vintage had the ability to do that. Down the bottom here is an interesting one, the mute button. That's actually a syllabic style of a squelch, and fundamentally you'll go to a channel which may or may not be active, but you want to listen to, and you can enable the mute and turn down the IF gain until it just cuts it off, and then if there's any audible signal within that channel, it'll come alive and you'll hear it. So if you're parked on on one of the airbands, say the South Pacific airband channels for the region here, which is 90% of the time it's not happening, and you just terrible, you don't want to hear the noise, you can defeat the noise by using that feature. I think that's fundamentally giving you some of the technicalities of the front panel: IF gain, audio gain, and this is, so let's see if AFC. This is the intensity, sorry. I always get this dimmer wrong. It's one of the least used pots on the board, I think. And it's never particularly hugely bright. I mean, that's full brightness up there, and it's about, I'll just leave it at halfway. What I will say is it's an attractive receiver. It's one of the prettier receivers that I've had the chance to play with, and it's reasonably well laid outside. It was obviously made for a cost. It's Eddystone historically addressed the maritime and the industrial professional user, whereas your Rakels and Marconis were more geared at the armies and the air forces. So you look at a receiver here which would be even half the price of a Rakel or it's still expensive in the day, I'd imagine, but it wasn't intended as a militarized receiver, just a hard-wearing industrial receiver. And it was a bit of a leap ahead from some of the earlier receivers they had, which were sort of analogy, and even in the 70s and 80s or the 80s, they were quite basic receivers. But internally here, it's a new departure, I think, for them. It's nicely laid out. Again, I'll show you later on. Now, this particular receiver, again, first receiving it just didn't want to work at all. First of all, there were a number of the typical dead capacitors and blown bits. But the biggest problem I had with this receiver was that the IF board and the RF board, which are both in the upper part of the chassis here, are literally stuffed with these little electrolytic capacitors. These are the true wet electrolytic capacitors, and aluminium electrolytic. And maybe 6 or 8 out of 10 were dried out, all bad. In the end, I gave up trying to hunt them down and pull one out of the other. I took both boards out, ordered a complete suite of capacitors, and replaced it over a weekend. We're talking some probably 60, 70, maybe more capacitors had to be replaced. The only thing I can think of is that this particular set was somehow in a rack at the top of the rack, or was left with no ventilation, and the heaters just cooked these, dried these electrolytics out, and that might well be the way it's gone down. Anyway, I'll give you a quick tour of the sensitivity and the playing. Right now we're on, this is Radio New Zealand, and it's coming in. I'm off the loop, which I favour at the moment, and it gives me the ability to select. It's a 2-loop, it's an orthogonal loop, cross-loop solution, and I can go for both loops together or off one loop, and you can see there is some improvement here on the A loop. Well, I was certainly showing that earlier on this evening anyway. I also have an LF filter in there, I can take it in or out. Really, that's just for some of the wider band receivers I'm using to make sure the broadcast band doesn't overdrive the front mixer. So currently we're monitoring with no input attenuation. It's AM band, it's on slow, probably should knock it down to the fast. And we're just on what we call the wide, which is the 8 kilohertz. There is a slightly wider filter, basically that's using the front end filter. It's something like 16 kilohertz, 15, 16 kilohertz. But arbitrarily, the wide would be the way to go. We can see that the RF2, the IF attenuation, AGC is up, and it's active. In fact, if you go to the RF, it probably won't even be, not even flagging. It's just not even engaged, because it's just not reaching a high enough level to start to activate the AGC on the RF front end. Excuse me. So that's the AM side of things. Now, I haven't listened this evening yet, but I'm going to go up to 14. So we have the unit in the tune section. You have to, I could manually tune, but I'll dial in the frequency. So it's 1.4, we'll go 2. Now, say, I don't know if the band's open or not. Go down to USB, select SSB, which is interesting. It's not automatically selecting the filter for the SSB, which, I don't quite know why they didn't link that. But anyway, it is what it is. Let's have a quick listen through. Now, the tuning is proportional. With the slow rotation, it just moves every 5-10 kilohertz, 5 or 10 hertz, sorry. And if you start spinning it faster, it changes the step ratio and increases. Sounds like the band's actually Probably dead. It is getting on in the evening here. It has been open, but I don't hear anything. Or very little. Let's just try 40. And we'll just switch it to lower sideband. Wow, it is really dead here tonight. Let's just see if there's anything on the FT8 then, just to make sure everything's even quiet on FT8. I can't believe that. It's very surprising. Okay, I didn't have it switched to upper sideband. So, looks like the band's awake, but pretty poor condition. And I'm just really surprised we're not hearing anything, any takers there. Let's have one last bash and go for... We'll work down from here. No, and my last go will be with... You can hear the slight delay before the signal comes up. That's the pre-selector moving in. No. You can hear the very, very weak signals tonight. And just to give an idea of what WWV may be doing, you can just vaguely hear it in the background. And what I will do is just quickly go on to the broadcast band where we know there'll be some signals, and just have a look at the some of the stronger signals here. Actually, let's go through that. So we'll go to AM, and we'll go up to there.
These remarkable artifacts buried in a tomb.
So this is one of the stronger signals. My home is within a couple of kilometres of just 3 or 4 major transmitters, and this is one of them. It actually flattens everything around me. Now that's with the filter in. Now that obviously is the maxing out the IF AGC, and if I go to the RF, you'll see that it's actually coming up. So if I was to put the attenuator filter in again, filter puts about 40 dB in, just enough to cause them, remove any issues. So very strong signal there, and as we go down through the band, we can hear it's pretty much all I know. It's being the loops and the low frequencies, they just pull absolutely everything in. I've late at night used the loops, and you can hear down to Melbourne, to be honest, which is 2,000 kilometres away, which is quite interesting.
Now, 30 minutes of continuous classic hits with more variety and less talk.
Classic hits 48.
So this is one of the local stations as well, very close. So we'll move even further down. We'll see if we can hear the NDVs, just to show the receiver can get right down there. Now, there's one there. So, I'll see what on there. I don't know if we can get down to. No, the CW filters. Leave it on the line for a moment. So, just going to a sideband. So there's a fairly local. And again, there's another one a bit further up. And there's the Gold Coast one down at 2. You can hear it swapping the filters, front end filters over there. Let's do that. So unfortunately, we didn't have too much success with some of the higher frequencies and the SSB, but it does cover 10 kilohertz all the way through to 30 megahertz. This is so the input pre-selector gives you that extra selectivity which you're probably looking for, and I've been quite happy with it. It's run very well. I'd say it's a pretty receiver. I'll pop this into a little sub rack before long and just have it on the other side of my desk, and it'll probably become one of the more used receivers. The only thing I don't like is the tactile buttons. Just a little bit fussy. As you see me trying to dial in the frequencies there. Just tricky. It's kind of like the Raycall 6870 and sorry, 67. What was it? 6790. Sorry. And it's a little bit easier, but this is quite tricky. In fact, I think these are a little bit harder to actually engage. But I'll just pause it there, and I'll just give you a bit of a look inside for a bit of a tour. So here's the internals of the receiver. It's a steel fabrication. It's not aluminium. It's quite heavy, and I'll go through. So from the front, again, it's traditionally all the CPU work is done at the front of the unit, and it goes by a ribbon cable to the various sub-assemblies for control features. There is a battery inside the main CPU system, which I replaced. Really, it just holds the memories and ensures that when you first switch on, it's actually doing the right kind of. It switches on at the last known state. All right, so we're working through from the front end all the way through. So from the received antenna at the back, it goes through on the underside here, a pre-selector system, and emerges up onto this deck here. There are a lot of read relay switches on here for various reasons, and some for the attenuators, some for the filters from the back here in the background. But essentially, the front end mixer is a Plessey IC. It's obviously running at some high current. IP, I'd guess to be in the 30s. I would guess. It's also the same mixer that's used a bit further back after the front end. So it's mixed to something like about 40 odd megahertz. Then it goes through another layer of first IF, mixed again down. This is, I think, part of the oscillating system, the drive for the mixer, and from here it goes into the IF at the back. And as you can see, there are 6 crystal filters in this guy, and that would probably be the majority of the cost of the receiver. And I was happy to see that these are all still functioning as they should, and as I say, they all give the requisite performance and filtering as need by. What I did find is one of the read relays had been damaged, so this is a replacement. These are unobtainable at the moment, but the same footprint is available in a different package arrangement. So again, that's in there, and all the way through. So what happens is it selects the filters via a switch, a relay switch. And here we are to the main IF system, where all the SSB, CW, and AM detection is done. And as you can probably see, the amount of electrolytics in there, absolutely every single one of those has been replaced, as the same as in the front end. And once that was done, everything just worked fine, and tried to set up. It was a nightmare before that. Don't think what's in here. I think there's a part of BFOs and the IFAF wideband gain system here. A lot of this is just the outboard sort of control for the RF path, as it would be. And down here is the audio amplifier and audio switching. Now on the bottom is fundamentally the pre-selector, power supplies at the back, which is again like 3 terminal style regulators. All seems to work quite well, so there's not been an issue with any of that. So that's the internals. If I was to purchase one of these, or if you're looking at purchasing one of these, a couple of things to look at. Obviously, make sure the crystal filters are fitted. I recently had a purchase of a receiver, got it here, and someone had pulled the crystal filter board, the most important thing in there, which was very disappointing. So yeah, make sure everything's fitted. Ideally, the VFO version. If you're going to go down this path, don't go any other way. I think it's going to be a lot of heartache to get anything else other than the stock unit running. But yeah, nice receiver. Really like it. Same, it's one of the prettiest receivers I've used, and it performs very well too. So that's the Eddystone 1650.